Welcome to my restaurant surface calculation. This is the optional method. If you want to see a standard method, please check out that video. We're going to be going over the 2023 NEC. Now I do have a 2020 video also. There really haven't been many changes. Mostly just code references have changed because they did a little reorganizing in 2023. And then this is a crash course series, so we're going to be going fairly quickly through this. If you want to see a more in-depth explanation of a commercial calculation in general, check out that video. I'll have all these links in the description below, or check out my channel for others. Okay, before we get started into the calculation, I wanted to talk to you a little bit about a change that they made in 2023 to Article 220. And we're going to take a look specifically at the parts that we're dealing with here, which is Part 2, 3, and 4. Now, this is an optional method, so our current calculation with the restaurant is found in Part 4, the optional method. And as we'll see in a moment, 220.88 gives us instructions on how to apply Part 4. But first, let's talk about what the changes are. So in 2020, in Part 2, you have 220.10 and 220.12. And what these together do is they instruct you on how to come up with your minimum lighting load. And then you would use that minimum lighting load in either Part 3 or Part 4, depending on which one you were going to be using for the calculation. Well, in 2023, what they did was they moved 220.10 and 220.12 into Part 3 and relabeled them 220.40 and 220.42. So now your minimum lighting load is found in Part 3 and not in Part 2. Now that doesn't make a whole lot of difference for most calculations, but for restaurants in particular, and also schools by the way, it does make a significant change. And that is because we are told in 220.88 that the calculation of a service or feeder load, where the feeder serves the total load for a new restaurant, shall be permitted in accordance with Table 220.88 in lieu of Part 3 of this article. So what they're saying is you can use Part 4, but only at the expense of Part 3. So you have to exclude Part 3 in order to use Part 4. Now that wasn't a problem back in 2020 because the minimum lighting load was found in Part 2, not Part 3. Now it's found in Part 3, which we're excluding. So therefore, we no longer can use the minimum lighting load when applying Part 4. So that's a pretty significant change. And I don't believe that that was the intention of the code making panel when they made the change. The original reason for this change, I believe, was just some housekeeping to kind of tidy up the calculations and keep Parts 2 and 3 separate from each other in a more logical sense. And I like that they did that. But the unintended consequence, I believe, was how it affects this restaurant calculation, and like I said, also schools. Those are the two that get affected by this. So I don't think this is their intent, and I think they're probably going to make some changes or add some clarification in the next cycle. I'm hoping they will, because as it stands right now, Part 3 is exempted from the calculation, and therefore that knocks out our minimum lighting load from being used in 2023. Okay, that being said, with this video, I'm going to go with my gut, which tells me that they didn't intend this to be the consequence, and so we're going to continue to use the minimum lighting load in this calculation in this video. But at the end of the video, what I'm going to do is I'm going to put in a slide that explains what it would look like if we took it at face value and excluded the minimum lighting load, and how we would do that and apply that to our calculation. So keep an eye out for that near the end of the video. Okay, we will get into it. Okay, now that we've got the ramifications of that change out of the way, I want to give you another, maybe a better overview of how this is going to work with 220.88. And I think it's important to understand how the article works, how it's laid out in order to get what they're wanting here. So remember that any load calc starts out with Part 2, where we calculate all our branch circuit loads. And then we typically have the choice of going to either Part 3 or Part 4 to apply demand factors. Again, Part 3 is the standard method, and Part 4 is the optional method. Now it's important to know that you can't take just a portion of each of these and kind of do a hybrid. You have to either take Part 3 or Part 4. And that's exactly what we're told in 220.88. Let's read it again. And this is the full section here. It says, calculation of a surface feeder where the feeder serves the total load for a new restaurant shall be permitted in accordance with Table 220.88 in lieu of Part 3 of this article. Okay, we talked about this on the last slide. In order to use Part 4, which is where 220.88 is found, we do that at the expense of Part 3. So Part 3 is not going to be used for this calculation. And we covered that in the last slide. Now let's move on. So the next three things here are not going to be covered in this video because it just talks about the overload protection of service conductors, and the next one talks about feeder and service conductor ampacity, and then the last one talks about the neutral calculation. And we're not concerned with that in this video. That's for some other videos in the future that I'll be doing when we get into sizing conductors and such. So you don't have to worry about these last 3 points for our calculation here. Okay, I think I've given you a pretty good overview of how this section works, and so now we're going to jump into the calc. Here is a table that I put together to give you the whole calculation in one shot, so you can see everything at once. I'll just explain this really quick, and then we'll get into the example and work through it. We're going to take the square footage of our building first, then we're going to get a multiplier, we're going to end up with a minimum lighting load. Then we're going to take all of our other loads, including the kitchen equipment, but remember, kitchen equipment has to be taken at 100% in this calculation because it is in part 3 that you are able to take the kitchen equipment at a demand factor. Well, we're not using part 3, we're using part 4, so that does not apply. So kitchen equipment is at 100%, as are the rest of these loads, unless they are continuous loads, which you would take at an extra 25% also. Speaking of, next we're going to take sign and outline lighting at 125% because they are continuous, and the show window lighting at 125%. Once we have all these values, we'll add them up and get a subtotal. We're going to slide that subtotal up to the upper right hand column, and then we're going to continue on with our other loads from 220.14. We're going to do fixed multi-outlet assemblies like plug strips and such if we have them, receptacle outlets, any other outlets, anything else that wasn't covered before will fall under this category. And then in the very last, we're going to take C again, a part of C, because we did cover motors in this section over here, but now we're going to take the largest motor of the whole building and add an extra 25% to that and put that here. That's going to give us our branch circuit total. This is our connected load because it's everything just totaled up. No demands have been applied. After that, we're going to go to table 220.88, and that's where we're going to find our demand. And basically the way this works is it's a demand on the entire total. This branch circuit total is what you plug into this formula in this table. And then that's going to give us our total building VA. After that, we can divide by our service voltage, taking into consideration our phasing, and that will give us our service amps. Then we can start to size our feeders, our conduit, and our service equipment. Okay, so here's the example we're going to use for our restaurant. It's 7,200 square feet. We've got some track lighting, some show window lighting. It tells us our receptacle load. We have some ceiling fans, exhaust fans, an AC unit, hood fan, and a couple of hand dryers. Now this is important. It says our heating is gas, and so are our grills. So that's going to take a big load off of our electrical service. Then we have our kitchen equipment all listed here. And the reason I have it listed separately here is because that's the way you typically do it, like in a standard method. In this case, though, we're just adding them all up at 100% anyway. So it just goes through all the ovens and ice cream, soda machines, and so forth. And then we have 120 208 volt 3-phase service, and we're going to find our load. All right, so we're going to start with the square footage of the building. We find that over here, 7,200 square feet. So we're going to just put 7,200 right here. And then we're going to find a multiplier, and we're going to go to table 220.42a. 220.42a says general lighting loads by non-dwelling occupancy. So on the left here, you're going to have your occupancy types listed, and we're going to go down to restaurant, and it's going to tell us we have 1.5 VA per square foot. That's our multiplier. So we're going to plug in 1.5 here, multiplied by 7,200. That's going to give us a minimum lighting load of 10,800 VA. Next, we're going to go on to our other loads, and this is going to be most of our calculation here, really. We're going to go through track lighting. We're going to add 25% to that because it's continuous. Also, our ceiling fans are going to be continuous because they're going to pretty much run all day. We're going to have some exhaust fans, our air conditioner, our hood fan, our hand dryers, and then all our kitchen equipment at 100%. So you can see everything listed here. What I did was I just took each of these line items, including all the kitchen. I added all the kitchen together in one, and it comes up to 67,430. And so that takes care of our other loads. Next up, we're going to get onto our sign and outline lighting at 125%. Now we're not told we have a sign or outline lighting, but it is required. you go to 600.5a and it tells you that one circuit is required at 1200 watt minimum. Times 125% is 1500 VA. Next, show window lighting. It does say we have 70 feet of show window lighting. So we just multiply 70 by 200 VA per linear foot. That gives us 14,000 times 125% is 17,500 VA. Once we have that, we're going to add up all these bold numbers and we come up with a subtotal of 123,810 VA. Okay, moving on to the next column, we slide our subtotal up here. Then we're going to continue with our other loads. And I should have said this before, but basically what you're doing here is these other loads here are just A through E. The rest of these, F, G, H, I, L, these are all specific loads that have specific requirements for how they're calculated. That's why they're separated out. These other loads are just at 100%. The rest of these have special provisions for them. Okay, so fixed multi-outlet assemblies, we don't have any of that listed. Receptacle outlets, we have 3600 VA, so we're going to put that here. Other outlets, we don't have anything. So now it's on to our largest motor. So our largest motor in this building is going to be the air conditioner at 16,000. So we're going to take 25% of that and add it here, 4,000. Once we do that, we're just going to add up these bold numbers again. And we're going to come up with a branch circuit total connected load of 131,410 VA. All right, now we finally make it to our table 220.88. It says, optional method, permitted load calculations for service and feeder conductors for new restaurants. So let's go ahead and read this note at the bottom because it explains how to use this table. It says, add all electrical loads, including both heating and cooling loads, to calculate the total connected load. Select the one demand factor that applies from the table, then multiply the total connected load by this single demand factor. So this is a very simple table to use. What we're going to do is we're going to take our branch circuit total connected load, 131,410. We're going to see which one of these it falls into. Obviously, it's 0 to 200 because this is the kVA column. So 200 kVA, it falls under that. So ours is going to fall under this first row. And then we have to choose, okay, is it an all electric restaurant or is it not all electric? Ours has gas heating and grill, so it falls under not all electric. So we find that our 131,410 VA falls into the 0 to 200, and then we are in a not all electric restaurant, so that's going to be a 100%. So this is the line we use for our situation. Therefore, as it shows here in the chart, you pick one of these, whatever it falls into, and ours falls into the top one, 131,410. The rest of these don't apply. So we're just going to slide down, and our total building VA is 131,410 VA. Now we can divide that by our voltage, but first we got to multiply our voltage by the square root of 3 because it's three-phase, and we end up with 365 amps. Now, real quick, in case you are wondering, what if our total had ended up being like, say, 250,000 VA, and it fell in the second line here, the second row? Well, then what we do is we go over here, we say, it says take 10% of the amount over 200. So if it's 250, then we are 50 over 200. So 10% of 50 is 5, and then you add it to 160. So 165. So then our total would be 165 kVA. Now if it was not electric, like ours, it'd be 50% times the amount over 200. So that'd be 25, right? 50% of 50 is 25 plus 200, so that'd be 225 kVA. So it's really that simple. It's a very easy table to use. Okay, and so here is the whole calculation all in one shot, so you can see it from start to finish. We come up with a total of 365 amps for our service. Okay, so now going back to what we talked about at the beginning of the video about the change from 2020 to 2023, I told you I would show you what that would look like if we did take it at face value. Basically what that means is here at the beginning of the calculation, this is our minimum lighting load, and this is where it's figured up. And since the minimum lighting load is now switched from part 2 of Article 220 to part 3, it's exempted from being used in the optional calculations. So what that would mean is instead of going for your minimum lighting load, you would take all of your connected lighting loads and just total them up. which means you would just add up all the lights you have throughout your entire restaurant and just add up their nameplate ratings, add up their VA or their wattage. And once you had that total, you would just add them to the rest of the loads, and then you would just continue on with the rest of the calculation, just like we've done earlier. Now, this is one of the reasons that makes me think this was an unintended consequence, and they didn't mean for this to be applied in this fashion, because it's very unusual for you to have to tally up every single lighting fixture for your load calc. And that's a lot of hassle. You'd have to have that information up front, and that's not practical usually. And it's so much more convenient to be able to use the minimum lighting load based off the square footage of the building. But like I said, we'll see what kind of clarification that they provide for us in the next code cycle, if any. Hopefully they will. Okay, here is a table that I blanked out all the info on. It's just a blank one that you can take a screenshot of, make copies of, do some practicing on, or use it for your actual load calcs in the field if you want. Do whatever you would like to with that. Okay, thanks a lot for watching, guys. If you found this helpful, please give me a like on it. And if you haven't subscribed, please do that. That'll help me out. It helps other people find these videos on YouTube because of the algorithm. I have a lot more videos out there. I have my 2020 series that I've done, and I'm working through my 2023 series now. And let me know what other videos you want to see based on the NEC or just on wiring in general. And I'll see what I can do. All right, guys, thanks a lot, and I will see you next time.